After you've provisioned a workspace, you can start to experiment with data. So here I am in my Azure Machine Learning workspace in Azure Machine Learning Studio, and I'm ready to start working with some data. Now I could just go ahead and create an experiment at this point, but I want to work with some data, and to get that data into here I need to upload the data sets that I'm going to need. Now there are some sample data sets that are provided with Azure Machine Learning to help you get started. But I'm going to upload some data sets of my own, and these are just some text files that I've got locally. So we'll go ahead and say we want to upload some new data sets, and I'll go and browse and upload. I've got one here that is a record of some exercise that my participants in a healthcare clinic have been undertaking. So I've been putting them through their paces, and they've been doing some exercise, and I've been tracking what's going on as they exercise. So I've got all that data in this exercise.csv file. It's a comma-separated file with a header, so I'll go ahead and upload that. And while that's uploading, it's uploading in the background there, I'll just go and upload another data set as well. In addition to the details about the exercise that they've been taking, I have details about the calories that they burned while they were exercising. So we'll go ahead and upload that file as well. And I can see I get this little kind of running status down here telling me what's going on. The first one is already completed, and the second one is on its way. So I can get rid of the first one just by clicking OK, and then do the same for the second one. So I've now got my two custom data sets uploaded into my environment ready to work with. So we'll create a new experiment at this point. And we'll just go ahead and create new and create a blank experiment, and we'll just call this calories, just for the sake of giving it something easy to work with. I don't need that map, so I'll just go and hide that. And what I get in the Machine Learning Studio is this environment here where I have on the left-hand side all the various things that I might want to work with, all the modules that might be involved in my experiment. On the right-hand side, I have a properties pane that relates to the currently selected thing. And right in the middle, I have this canvas where I'm going to drag and drop the various things that I need to work with in my experiment. So a lot of times, if you are creating machine learning models, you might do it in code, you might do it in Python or R or any of these other languages that are used for this type of thing. And you can do a little bit of that in here as well. But the nice thing about Azure Machine Learning Studio is this drag and drop environment just makes things a little easier. So I'm going to get my data sets, and we're just going to grab those. So I've got calories and I've got exercise. So we'll drag them out, and there's not a lot of room to work in here. So I'm just going to drop the zoom down a little bit so we can see them both. And I can see I've got these modules, and each of the modules has this little output port. And if I hover over, I get the name of it. It's called data set. And I can always visualize that if I just right click and click visualize. And when I do that, I can see the various columns and some previews of the data in there. So I can see there are 15,000 rows of data, there's 8 columns, and I can select each column and see what's in those. So I've got the user ID, the gender, the age, the height, the weight, how long they were exercising for in minutes, their heart rate, and their body temperature. And I can see as I look at these, I can see the statistics for that data. So for example, if I take a look at heart rate here, I can see the mean heart rate, the median, the minimum, the maximum, and the standard deviation. I can see there are 59 unique values. There are no missing values, so we've got a heart rate measure for everyone. And I can see a visualization of that as a histogram, which as a data scientist is useful to me because I can see that looks like a more or less normal distribution that I would expect for some sort of randomly sampled data. So I've got the ability just to kind of get a quick look at the data using this ability to visualize it. Now I've obviously got these two data sets, and one of the things I'm going to want to do is connect them up. So I can go and add a module. We'll just use this join data module. And I can drag in the left and right. So it's just drag and drop, and I can start to connect up my data flow. I see a little red warning line here that says something's not quite configured properly yet. And that's because I need to tell it how to join these two data sets. We've seen the exercise data. If we take a quick look at the calories data, we'll see what's in there. And again, there's a user ID and the number of calories that was burned during the exercise session here. So what I'm going to do is I'm going to launch this column selector, which is going to let me select from the available columns which one I want to join on. So from the left-hand table, which is my exercise, we'll take the user ID. And from the right-hand table, well, I can do the same thing again. I can select from the available columns. There's also this option to select using rules. So I could begin with none of the columns and then select the ones I want, or begin with all of the columns and then exclude the ones that I don't want. I'll start with no columns, and I could choose by various different criteria to find the columns I want. I'm just going to use the column name here, and it's the user ID that I'm after. So there's a couple of different ways of selecting columns. I can do that, and now my little red warning has gone away because I've got these linked. There's still a little bit of configuration I want to make. It's a number, so the match case won't matter. I do want to change the join type. I'm going to make it a left outer join so that if I do have any exercise records where I don't have the calories, I'll still keep the details from the exercise side and just have a null value for the calories there. And then the other thing that I want to do is I want to specify that I don't want to keep the right key column. I don't really need two copies of the user ID column, so we won't keep the right-hand one, we'll just keep the left-hand one. So now if I try and visualize the output of the join, you'll see that it's grayed out at the moment, and that's because I have to run the experiment at this point. So we'll go ahead and run it. And that's just going to, first of all, queue the job and then start running it and just push that data through. I can see a little green tick that tells me it's finished running, and now I can visualize the output of that join. So that's pretty useful. I can see user ID and all the way along, and then I've got the calories joined on the end. So I've now got all the data that I need to work with to start analyzing how do the various different metrics that I've measured when people are exercising relate to the number of calories that they burn. Now I could continue to build up this experiment here, but actually what I want to do is start visualizing the data using something called a notebook, a Jupyter notebook. And to do that, I'm going to have to convert it into a format that I can open up in the Jupyter notebook. So I'm going to convert it to a CSV format. That's how it started, but of course it started going through this workflow now, so there's an internal format that's being used. So we'll just convert it back to CSV, and I can just run that selected module, so I don't have to run the entire experiment again, just that one module. And when that finishes, I've got my CSV output, and that means that I can right-click on here, and rather than just visualize that, I'm going to open it in a new notebook. And I can choose the language of the notebook that I want to use. In this case, I'm going to use Python 3. Now, I'm choosing Python, and throughout this course, we'll use Python as the kind of programming language of choice. It's a really commonly used programming language by data scientists and AI engineers. So you can use other languages. You could use R if you prefer, and later on when we look at building software, you could use any language you like C# or Java or anything like that. But we're going to focus on using Python in this course just because it's commonly used with data science. And you can see that it's already populated a couple of these things that we call cells in my workbook. It's got some code here that really is just setting up the environment, connecting to my workspace, and getting the results of that output, that generic CSV output. So if I go and run that, I get a little circle here, very briefly filled in there as the kernel was running, and then it emptied to tell me it had finished running. And now I've got the command frame, which is just going to show me the data frame containing the data that has been extracted from that CSV file. So here's all of my data. I can see all of that in there. And I'll just collapse that just so it doesn't take up quite so much room. Really what I want to do is actually visualize that data. I want to see the relationships in the data, and a great way to do that is to write some code that will generate some sort of chart or visualization. So I've actually got some code here that I'm just going to use, and I'll talk you through it briefly. Basically, we are using something called matplotlib, which is the library within Python that's used for plotting things visually. And I've got this little percentage sign here. It's what we call a magic, and it's telling this Jupyter Notebook environment that I want to display my graphics inline when I run it. So we're going to display the graphic inline as we run it. I'm importing a library called Seaborn, which is a library that has a lot of different built-in functions for creating data visualizations. I'm specifying that I only want to use these numerical columns: age, height, weight, duration, heart rate, body temp, and calories. So these are the numeric columns in my data set, and I want to see how they compare to one another. A lot of machine learning is based around correlation and relationship between numeric values. So we'll take a look at what those look like. And we are going to create something called a pair plot. And a pair plot is basically just a scatter plot, the different, plotting each numerical value against each other. And we're going to do that as a grid. So we'll see a kind of overall scatter plot matrix with visualizations of every numerical column compared to every other numerical column. So go ahead and run that code. I get a little warning because it's importing a library, and there's a few kind of warning messages as it does that. But then what should happen when the code is finished running is that we get this visualization, and I can see here all of those numeric values compared to one another. Now, some of them it's just a mess of points where we're comparing. In that instance, we're comparing height to duration. So there's not really any sort of relationship. And you wouldn't expect a relationship between someone's height and how long they exercised for. But there are some interesting shapes here. I can see that there's a kind of diagonal line here where weight seems to have a correlation with height, which kind of makes sense. Someone who's tall is probably going to weigh more. So I can see there's a kind of relationship forming there. And I can see, as I look down here, there's a relationship here between duration and body temperature, and it's kind of a curved relationship. It's what we call non-linear. It's not a straight line that gives me that relationship. It seems to sort of curve as the time goes on. We get a sort of more curved relationship with the body temperature. And similarly with my duration and calories, it kind of curves the other way. So there's some relationships in here that aren't exactly linear, and I might want to play around with the scaling and the mathematics of some of these numerical features to straighten out those relationships and make them easier to deal with. But it gives me a good overall view of what the relationships are between the different numeric values in my data set. So when I've visualized all of that, I can go back to my experiment and carry on working with my data until I'm ready to clean it all up, prepare it all, and build a machine learning model. And that's what we'll talk about next.